Today is Laboratory 5, Mechanical Properties of Timber. We're going to start with bending strength. For this, you're going to need to know the depth and width of a beam, as well as the distance of the clear span in between its supports. You're going to load this beam up in flexural bending and record the deflection every quarter of a kilonewton applied. Notice the bending action occurring in the beam. This causes a lot of internal forces, as we learned in class. The forces look something like this. Now, if you take note of the failure that has occurred, you'll see a lot of similarities. The tensional failure at the top, which was on the bottom, and the shear failure right in the middle. Now we're going to prepare our parallel compression test sample. This is when you load your specimen up in the same direction of the wood cell growth. Measure and record the dimensions of the specimen before placing it in the testing machine. Ensure the dial gauge is in place and record the deflection and loading every 200th of a millimeter. Once your specimen fails, remember to report and compare the failure type to what you can find in the lab manuals. Now we're doing compression perpendicular to the grain. As you can see, this is perpendicular to the wood cell growth. Place your specimen in, laying on its side after you record both the height and the width of the specimen, as well as the surface area that will be pushing against it to calculate the stress. Read the dial gauge reading and record your loading and deflection every 1/5 of a millimeter. Once your specimen fails, record and report the failure type, as you will use it in your lab write-up. Once you analyze all the data gathered, you will probably notice that wood is much stronger in parallel to the grain.